How can we give name to this molecule? The alcohol part, 2 carbon, so it will be an ethyl, and the acid part, sorry, I made a mistake here, CH2, CH3. Okay, and the acid part has 3 carbons, so it's a propanoid. So the name will be propanoate. Okay, so ethyl propanoate and so on. And in chemical reaction, if you make a reaction like this, if I have a C6H5OH, it is a structure which is similar to alcohol, and we call it phenol. Suppose it reacts with an acid like a propanoic acid. Propanoic is CH3, CH2, COOH. Propanoic. So what will be the result? We'll take the OH from the acid part and the H from the alcohol part to form water molecule, and then you will copy the structure C6H5O CH3, or sorry, here, and then what we should write? C double bond O, CO, CH2, CH3. Okay, CH2, CH3. So, and the name, the first part was phenol. So this part we'll call it phenyl. You add YL. And the acid part has 3 carbons, so it's a propanoid. So the molecule will be propanoate. So a phenyl propanoate. Yes. Yeah, so sometimes you will be given in the exam the formula of the ester, and then you are asked to give the name of the alcohol and the acid part that form it. What? No. If the molecule is like this, CH3, CH2, CH2O, and then CO, CH3. Okay, and then first give the name, and second give the acid and the organic acid and the alcohol that form this ester. The name of the molecule, we cut through the ester bond. You know the bond between COO. This bond we call it ester linkage or ester bond. Okay, so we will cut through the ester bond and then give the name for the molecule. This part is the alcohol part. It has 3 carbons, so the name will be propyl. For the alcohol part, we put YL. And for the acid part, it should end with OATE. It has how many carbons? 2 carbons. So it's the ethanoic. So we will say ethanoate. So what is the alcohol? The alcohol that form it is the alcohol is propanol and the acid is ethanol. Okay, the acid is ethanol, and so on. When we make this reaction in we add sodium carbonate. Okay, sodium carbonate react with the acid, the excess acid, and remove it. When it get removed, it means you don't have the smell of the acid. In this way, you can feel the smell of the ester. This also will be added by adding the sodium carbonate that react with excess ester, forming carbon dioxide. You know, carbon dioxide make bubbling or effervescence, so the smell of the ester can be easily detected. Okay? Yes. I said ester has fruity smell or flowery smell. They have a very nice color, nice flavor, smell. Yes, to remove the acid. Okay, to remove the acid. Ester, ester is made of one molecule of glycerol and three molecules of fatty acid. Each fatty acid has RCO and here O, RCO, O, RCO, O. This is the formula of the organic acid. And COO is the ester bond. We said R is alkyl. R is alkyl. It stands for CnH2n plus 1. This is R. Some of in case of fats or in case of fatty acid, because RCOOH is an acid, fatty acid. Some of the R have double bond. So if the R is double bond, the fatty acid described as unsaturated. But if R all bonds between carbon atom are single, it will be described as saturated. And we said that before that if so many unsaturated acid presence in the fat or lipid molecule, so the fat molecule or the lipid molecule will be liquid and it makes an oil. While if R were saturated, if all R's were saturated, the molecule will be solid or semi-solid and it will be called fat. Which book? What are you saying? يعني ايه empty? I didn't get. Maybe I didn't start in polymerization. I'm talking now. I'm talking about making fat. Okay, how to make fat? You add sodium hydroxide. Okay, we add sodium hydroxide. I have a call. I have a phone call. Just give me 1 second. To make fat or oil, we add sodium hydroxide. Sorry, to make soap. We add sodium hydroxide to the molecule of fat or oil. So the name of the reaction, we call it alkaline hydrolysis. Alkaline hydrolysis. Hydrolysis means breaking down of the molecule. So we can expect here that the molecule of fat is going to be hydrolyzed or broken down into its components, which are the fatty acids and the glycerol. And the alkaline means the breaking down or the hydrolysis happen in presence of an alkali. Guys, it's so bad, wallahi. Please don't touch my desktop. Okay, so the molecule of fat are COO, and here are COO, and are COO. And here we are going to put the part of the lipid, the glycerol part. Yes. So again, the process of condensation happens between a molecule of glycerol and a molecule of fat or oil. Here, the hydrogen is taken from the alcohol and the OH is taken from the fat molecule, releasing three water molecules. And a molecule of fat or oil will be formed. Breaking down of fat or oil happen in presence of an alkali, not in presence of water. Happen in presence of alkali. Here, we cut through the ester linkage between CO and O, and then to each O we add H. Here, for each part of the alcohol, each O will take H to form a molecule of glycerol, which is an alcohol. And the ONA will be added to the rest of the molecule, RCO, ONA, RCO, ONA, and so on. So these are sodium salts. This sodium salt of the acid, this is the formula or the molecular structure of soap. So if you are asked what is soap, you need to write this, the sodium salt. Sodium salt, this is the formula of soap. Yes, we take OH from the fat. I didn't get. Uh, hmm. This is the fatty acid. We remove OH from the fatty acid part. خلاص. لكن when we join, they join in a different way. Because when you remove the OH, I have RCO. RCO will take the ONA from here, from the alkali part. Yes. This is CO. It's not COR, it's RCO. RCO-ONA. RCO-ONA. RCO and take ONA from that part. This is soap. It's a sodium salt of fatty acid. It is sodium salt of fatty acid. The fatty acid is RCOOH. Sodium salt is RCOONA. Okay, thank you. What will be wrong? What's wrong with that? It's R also. It's still an R. Okay, what's wrong with that? No problem. It's different types of soap. Some soap are more soft than the others. That's it. Yeah, the soap will be more soft. And guys, I was recording. When anyone touches the board, the recording stop. Wallah, you're touching. Because I shared the whole screen with you. The whole desktop. Okay. So let's repeat it again. So condensation is a reaction between two monomers to form a polymer or a structural unit of a polymer. It's not a polymer, just a structural unit. Okay. And the small molecule will be given out like water molecule. And we give an example for this, a reaction between alcohol with two hydroxyl group, we call it diol, with a carboxylic acid with two carboxylic acid group. Okay, we remove the water molecules, but remember, we remove the OH from the acid and the H from the alcohol, and you will form now the structural unit of the ester. So what we call this? This is the structural unit of what? Of a polyester. Because if you make the process of esterification so many times, if the same process have been repeated so many times, you will have what? You will have a polyester. If you are asked to write the formula of the polyester, you will write the same thing, but you just need to put an N, to put N. So like this, O. Mute your microphone if you have noise at home. Okay. So this is the polyester. So the first one is a structural unit. So sometimes you are asked, draw one unit. Draw one unit, just draw the unit. Without N, without bracket, without anything. Just draw the unit. If you are asked to draw the polyester, so this is the polyester. Because I wrote N, mean the same molecule is repeated, this formula is repeated so many times. This is polyester. Okay? Okay. Okay, خلاص. So the polyester is a synthetic polymer. We have an example for the polyester, which is terylene. It's a man-made fiber, and it has an ester bond in the structure. Okay, polyamide, it's also a synthetic polymer. Synthetic polymer means it's a man-made polymer. The example of polyamide is nylon. Okay, and this one has what? Has an amide linkage. Okay, it has an amide linkage. And what is amide? I will show you now. So again, the polyamides are formed by the condensation, okay, of what? Of diamine and dicarboxylic acid. How the condensation happen? Removal of OH from the acid and the H from the amine. Okay, طبعا water will be given out in the equation. Sorry? It's a condensation polymerization, yes. We have two examples of condensation polymerization. The polyester and the polyamide. Both of them are synthetic polymers. Okay. Um, the amide linkage or amide bond is C double bond O N H. And you should keep open ends like this. Okay, so here, this is the amide linkage. Okay, CONH. Okay. Type here, for the ones that have amide linkage, they might be or synthetic or natural. Okay, the synthetic amide is nylon. I mean polyamide, sorry, not amide, polyamide. Okay, and here is polyester. The synthetic amide is nylon. Okay, the natural amide or natural polyamide is protein. For the esters, also we have synthetic and the natural. The synthetic ester is polyester. Polyester like terylene. Okay, and the natural one, the natural ester or polyester is the fat or oil that we have just described. Fat or oil is a natural ester. Okay. Proteins, proteins are polymers. Polymers of what? Polymers of amino acids. So they are formed by condensation of different types of amino acids. Yes. Amino acid is a molecule which has also COOH and NH2. The difference between طبعا the structure of the protein is completely different from the one of polyamide, and you will see now how. This molecule is amino acid, so as I can say amino acid A. It will undergo condensation reaction with another amino acid. So I make here like dots like this to make it different, but it has the same functional group, NH2 and COOH. Okay, normally any amino acid, it has both groups, amine group and the carboxylic acid group. You know, this group is amine. Okay, and this group is carboxylic acid. They are in the same molecule. How condensation happen? Normally, we remove the OH from the acid and the H from the amine. Here, remove the OH from that side and remove the H from the other side. And recopy the molecule again. So, here, and H CO, and then what's left from the other molecule, NH, and the box, and CO. Okay. Where is the amide linkage? Okay, this is the amide linkage. Okay, this is the amide linkage, and this is the unit of protein. So now, what we call this, طبعا هنا we are taking two water molecules, so you need to write 2H2O. Okay, when two amino acids, you know this from biology, when two amino acids join together, they form what we call dipeptide. Okay, because also sometimes, let me finish. Sometimes the amide bond, the amide linkage, we call it peptide bond. And it's not wrong to say peptide if you are talking about a natural polymer. So natural polymer have a peptide or amide. Okay? This is a dipeptide. Sometimes you are asked to draw the polypeptide. Okay, polypeptide, draw the same molecule, the same unit, and this is the unit. You'll draw it again, but put N. So I'll draw it, NH, here, CO, NH, CO, okay? I did a mistake. You didn't recognize it. No H here, so okay. So here, we put this between two brackets and write N. So this is polypeptide. So now you get the difference when you are asked to just to draw polypeptide or draw dipeptide. Dipeptide, it's from reaction, like it's a normal chemical reaction. Condensation, we removed two water molecules, you should write 2H2O. And this molecule is dipeptide. But if you are asked to draw the structure of protein or polypeptide, draw the dipeptide unit and put it between two brackets and the right hand. Yes. Yes, don't say now to amino acid, say a dipeptide unit. It's a dipeptide unit. Okay, it's a normal, yes, yes. We remove H from the acid, H from amine to form the polypeptide or polyamide. Yes, sorry, what are you saying? It's a polypeptide. I write polypeptide. Poly because I put here N. This means that this dipeptide unit is repeated so many times. So it's a dipeptide. Okay. You know that some proteins are enzymes, and the enzymes can work as a biological catalyst. Okay, they speed up reactions without being changed, and they are very sensitive to any change in pH or a change in temperature. So you know all this information from biology. Yes. Okay. I will show you now another type of hydrolysis. Sometimes in the exam, okay, sometimes in the exam you are asked to distinguish between amino acids, to distinguish between different types of amino acids or different amino acids in a protein. So first you need to hydrolyze the protein. Okay, how to hydrolyze the protein? You we can't use enzyme because we are working in a lab. So you hydrolyze the protein by adding concentrated acids and heat. If you add concentrated acid and heat, so you are going to break down the protein into the amino acids. And then to distinguish between the different types of amino acids, you undergo the process of chromatography. Yeah. In chromatography, you distinguish between different types of amino acids, depend on their size and their charge. Yes, yes, yeah. This is hydrolysis. Hydrolysis means breakdown. How to break down the protein? Add acid and heat for many hours. It needs like 2 to 3 hours heating until the protein is hydrolyzed completely into amino acid. And then in order to distinguish the amino acid, make chromatography. Okay? When you are making chromatography, you will put here the spot of your the unknown one, and you can put like 3 different types of amino acids of known RF value. Of known RF value. So suppose one will go to this point and this to this and like this. Okay, and then you are going to hydrolyze your protein. Okay, you're going to hydrolyze your protein. Sometimes the protein does have the amino acid that you are looking for, like this. So I can say that your sample or my sample contains which amino acids here? It does contain amino acid A and A and C, okay, but not B. Okay, and you know the procedure of chromatography. You get like the chromatography paper, draws the baseline with the pencil, and then baseline in a pencil. Amino acids are very soluble in water, so water here will be used as a solvent. Okay, and run the chromatography and then measure the RF value. And you know how to measure the RF value, measure the distance run by the spot over the distance run by the solvent. So if this distance is, if I say it x and this distance is y, okay, so the RF value will equal x over y. Okay, and in this way you can distinguish different types of amino acid. Don't please wait. The points that you will get here, they will be all of them will be colorless. In order to make it colorful, you need to add a locating agent. Okay, you add a locating agent to make the amino acid colorful. Okay, to be able to view them. Yes, I removed what? Now you can see the board because you open something else. You are playing. It's you. It's Habibi, someone opened this. I didn't touch anything. Hello. I will application window. Okay now. Okay. Okay, so in order to view your spots, you need to add a locating agent. Locating agent will react with chemicals. You know what is the function of the locating agent? React with chemicals in the spot and make them visible. You should write this. Make the spot visible. Please, if you stop talking, يعني خلاص, it will come, but just the internet is slow. طب خلاص يعني if you know him, I can kick him out. I don't open. I never open the whiteboard because I'm not using it anymore. And I don't have a control over it. Now you can see the screen well, sir? Okay. طيب I will tell you something. Take this code. Can you see this code? TEBEP. Can you see the code at the top right? Yeah. Okay. By opening this code, later on you can watch the whole presentation, and you can download it. Even you can upload it as a PDF file. You can upload everything as PDF file. Just copy this this code. خلاص. But when you open it, you need to open it in use the application. Use the application explaineverything.com. Okay. Any question here? Comparison is clear. خلاص. Okay. The last type of condensation polymer, you can see it in carbohydrates. Okay. You know carbohydrates like starch and the cellulose, they are all polymers of glucose. So the monomer is glucose. The type of polymer here is also condensation polymerization or condensation polymer. Okay, because it produces two products, one polymer and a small molecule. Yes. No, it's not addition. Two molecules are produced. Addition polymerization happen only if you have double bond in the molecule. If the molecule is unsaturated. In alkenes only. Only alkenes react by addition, and they make addition polymerization. And you will see now the structure of glucose. طبعا you don't need to learn the structure of glucose, but also to make it simple to you, we draw a box and write here OH, OH. Okay, this is one glucose. Here, but if I have two glucose units join, because I'm saying condensation is happening. What is condensation? Removal of water. Now we remove OH from one and H from the next. Okay, and remember that the one that if I remove from this sugar, I removed OH, so I should remove H from the other side. And the one that you remove H, you remove the OH from the other side. So finally, two water molecules will be given out. Yes. I remove water from each sugar, but this I remove one water molecule from each sugar molecule. H from one side and OH from the other side. ما في O خالص. Wait. Yeah, O box O. Yeah. Okay, so this is the unit of the polymer and the two water molecule. Okay. Of course, yeah, this will be repeated so many times to form a carbohydrate. Now you cannot say carbohydrate. I can say now this is a structural unit, because in the exam sometimes you're asked draw the structure of carbohydrate or draw the unit of carbohydrate. Structural unit. Okay, so the unit, the smallest unit of a carbohydrate is that one. Okay, structural unit of the carbohydrate. If you need to draw the whole carbohydrate, you should draw N. It's just unit. If you want to draw the carbohydrate itself, it's enough to okay, and here put N. Okay, I have seen it also in some papers. They can accept if you draw it more simple. So you can even just draw one box. like this. Mm. They accepted it like this. Oh, okay. Also, they accepted it, but I prefer that one. Okay. طيب يلا. Hydrolysis of starch. I don't know why I can't. Oh, because it's white. Okay. Hydrolysis of starch. It will give its components, which is glucose, right? So it will give glucose and water. Okay, remember that when we hydrolyze starch, we get only one type of molecule. So many glucose molecules, not like hydrolysis of protein. Hydrolysis of protein give many different types of amino acids, right? But hydrolysis of starch just give glucose and water. How we can make hydrolysis of starch in the lab? We add also an acid and heat, so you can hydrolyze it. Otherwise, it can be done by enzyme. So if you are asked what is the difference between addition polymerization and the condensation polymerization, in addition, yeah, addition, but yeah, let's make a comparison, addition and condensation. In addition polymerization, it happens when you polymerization of unsaturated molecules. Okay, it is the same repeat unit. Same repeat unit. So it is the same unit which is repeated. But in condensation, in most of compounds, we have two repeat units. The repeat unit is two, not more, except in glucose, except in starch, two repeat units. So if you are talking about the polyamide, is made of amine and the dicarboxylic acid. If you talk about polyester, it's made of dicarboxylic acid and the diol. So the condensation polymer made in most of the cases of two repeat units, not one. But the addition polymerization is just one repeat unit. Okay, condensation happened by removal of a small molecule, which is mostly water. Yeah, okay, from the two small units. I'm saying now, polyamide is made of what? Polyamide is made of dicarboxylic acid and diamine. So two repeat units. Okay, ester is made, polyester is made of what? Dicarboxylic acid and diol. So the repeat unit has two molecules. But in addition polymerization, the repeat unit has just one molecule. Okay? And as you said, here is just one product. Okay, but here it gives two products. One main product and one byproduct. Yes. Okay. Okay, now I think we are done. What's left is the part, the fermentation, right? Yes, anaerobic fermentation is anaerobic respiration. Yes. Okay. طبعا the amount of energy produced is not as in case of aerobic respiration, produces a small amount of energy here. And then in order to make this process, you get a conical flask, okay, and you add for it, we use here molasses. Molasses is a source of, it's a black honey, is a source of glucose, and you add some yeast. And because yeast is a living organism, so it's very sensitive to pH change. So you need to monitor and keep the pH at 7, and you need the temperature to keep it at 37 degrees Celsius. And then yeast has enzymes that are going to hydrolyze glucose into ethanol and the carbon dioxide. In order to collect the carbon dioxide, طبعا ethanol is liquid, so the ethanol will be left out here in the flask, while the gas will come out. Okay, and then you can collect it in a test tube or a boiling tube which has lime water. Lime water will turn milky, meaning that carbon dioxide has been produced. Okay, and then you can also feel the smell of ethanol. So the chemical test that we can use here, we can use lime water to test for carbon dioxide. Okay, but here I want to remind you that the equation, because carbon dioxide which is produced react with lime water. Lime water is calcium hydroxide, forming calcium carbonate and water. Calcium carbonate is insoluble in water, it's a solid. This is why the lime water will turn milky or cloudy. But if you pass the carbon dioxide for long period of time, so if you continue adding carbon dioxide to the reaction medium, carbon dioxide will react with calcium carbonate, forming calcium hydrogen carbonate, CaHCO3 2. Calcium hydrogen carbonate is soluble, it's aqueous, so the precipitate will disappear. Because sometimes you are asked in the exam, the lime water turn milky only for short time. Anytime lime water becomes milky only for short time. Why for short time? Because calcium carbonate is insoluble. So it's going to make the lime water milky. But for long time, calcium hydrogen carbonate will be formed, which is aqueous. It means soluble in water. So the white precipitate will disappear. When I say insoluble, I mean white precipitate will be formed. But this one is colorless. Okay? Yeah, لسه هقوله حاضر. Yes. The test for ethanol, flammability test. It's a chemical test. Sometimes you're asked physical test or chemical test. The chemical test for ethanol flammability, it catches fire. That's it. Catches fire. If you are asked to write the equation, the normal equation of combustion, like C2H5OH plus O2 will give carbon dioxide and water. Okay, this but ethanol catch fire is a very important test for ethanol. We need to block. Sorry. Okay, so it's a test for alcohol. Okay, yeah. No, not all alcohols catch fire. Who told you this? It's only ethanol, methanol, like this. Other alcohols don't catch fire. It's just a test for ethanol. It's a test, even if other chemicals are there or catch fire like ethanol, but it's a test for ethanol. Another test for ethanol, the physical test for ethanol, the smell of ethanol. It has a characteristic smell, or we can say an alcohol smell. Alcohol smell of an alcohol. Spirit. And everyone knows the smell of alcohol or the smell of whiskey like this. Sorry? خلاص, you write this in exams, so خلاص, they know, they will understand. Okay. You can. But here it looks better, and you draw something. If you draw one repeat unit, it will just be like this. This is one repeat unit. Or you can also draw O here, no difference. But it will be just like this. One repeat unit. And here you can put N. But if I put N, I need to remove this one. Like this, only like this. Okay? Yeah, colorless or pale, no problem. Yeah. So if there is no starch, it will be colorless because I'm explaining the result I have. يعني احنا you are not inventing results يعني give from your mind. You are describing what you can see here. At the start of the experiment, before enzyme works, starch was there, it gave blue color with iodine. At the end of the experiment, starch has been hydrolyzed completely, so no starch, the color will remain colorless. Okay? And then here, if the experiment was repeated at higher temperature, like 60, all the samples stay blue. Remember that we are working with enzymes. So, yeah, okay. Yeah. At this very high temperature, enzymes are denatured. So starch will remain in the reaction medium. Okay. فاهمين ولا لا؟ فين حبيبي فين ال 2H الموجودين يا ابني؟ فين يا ابني 2H؟ حبيبي this is carboxylic acid group يعني please don't mix things up مش معقول يعني this is carboxylic acid يعني اسميها carboxylic وشويه اخضر و H اسميها alcohol. Okay, and this is an alcohol group. Two different groups. Okay. فهمنا ولا لا؟ Okay. طيب إذا it will be condensation. تيجي addition منين ثواني بس sorry. How yeah I don't know what happened. Okay. Okay. Give reason for your choice. Reason, yes. Reason should be something in front of you. Don't say give two products. You don't have an idea here. You don't have a story about giving two products. But what we know, we do have. We have two functional groups. Okay, we have the OH group and we have the carboxylic acid group. This is why the condensation should be on the polymerization condensation. Anyone didn't get it? Which point? Okay. It does have both groups, right? Carboxylic acid group and the alcohol group. Okay. The condensation happens between them to form the ester. How the ester bond happens again? How the ester bond happen? Remove the OH from the acid part and we remove the H from alcohol part. So we will have COO. This one, COO. CO and O. So how this bond is formed? By condensation. We removed the OH from, we can say this here, even in the answer here. We take the OH from acid, okay, and we take H from alcohol. No. You will take one mark. You will take 1 out of 2. You can either say they have two functional groups, or to explain how water molecule is removed. It's not enough to say water molecule is removed. انت عارف ليه؟ Because I don't have an equation which has H2O. يعني أنا ما عندي equation here in this question that show that H2O is there. I just need to explain how COO is formed. COO is formed by taking OH from the acid and taking H from alcohol. And we are explaining what we have only. Here, okay, so complete the water equation for the action of heat on lactic acid. Yeah, saying here when lactic acid is heated, acrylic acid will be formed. So what we write? From where we get alcohol? How to write? Yes, yeah. So if you just subtract them, you will know that. Um, let's do it. C and C, H and again H here, right? Um, and then second C, H, COH, COH. Okay, H and H. What's left is only water molecule. Is it water or yeah, water? So, describe a test that distinguishes between lactic acid and acrylic acid. Yeah, we have here double bond. Okay, so we add bromine water. Don't say no color change. Give the color. The color will remain yellow or brown or orange in some books. Okay, and here, yeah, colorless. Yeah. Describe test other than using indicator that show that both chemicals contain acid group. They have acid group, so make a test for any acid. Add a metal like piece of magnesium, so hydrogen gas will be produced, which burns with a pump. So gas produced, yeah, contain acid. So make a test for any acid. Okay, put a metal. Put a metal. It will give a gas, which is hydrogen gas, burn with pop sound. Yeah, I wrote O2. Yeah, you should write oxygen. Okay. Then this decomposition reaction of silver bromide, you know, this test which we use it in redox equation to in photochemical reaction, because silver bromide is white. When it's exposed to a light, it will form a black silver and bromine. Just let me tell you what happened in this equation. Silver bromide was having silver ions and bromide ions. This is silver bromide, right? When you expose it to sunlight, it's undergo redox reaction. So silver ions will be reduced to silver, while bromide ions will be oxidized into Br2. Okay, silver is brown or black, so it's going to give a black color and darken the film or darken the paper, darken the white paper. The process of darkness depends on the intensity of light. So if there is no light, it will remain silver bromide. If there is dim light, okay, or the exposure for light for a short period, so it will give a gray color. If the light was so intense, the reaction will be completed, forming many atoms of black silver. And this is why here, the one which is covered with thick card means no light. Okay, thin paper means a small amount of light, and here is large amount of light. So the question is asking, explain your results. Okay, how to explain the result? First, mention that the one which the reaction is photochemical. Yes, then there are 3 marks here. Yes, you will say that the one which is not covered, silver ions. Much of silver ions will change into silver, which is black. But the one which is covered by thin layer, so small amount of light, so small amount of silver ions will change into silver. While the one which is deprived from light, no reaction happens, so they will remain white. You are going to give all of this explanation. we have a mole question here. It's a neutralization reaction between lithium hydroxide and sulfuric acid. He gave you the volume of lithium hydroxide and its concentration. And he is asking about the percent yield of the reaction. You know, in order to calculate the percent yield, we need to first know the actual yield and divide it by the calculated one. So it's the actual yield divided by the calculated one that we got it from the stoichiometry of the equation into 100. First of all, we are going to use the volume and the concentration used in order to find the number of moles. Number of moles, N equals CV. So you will multiply the the concentration into volume, and don't forget to change the volume from centimeter cube to decimeter by dividing over 1000. So we got here, the answer was 0.062 moles. And then you are going to work out the mole ratio in order to find the number of moles of lithium sulfate. Working out this equation, you will see that the mole ratio between lithium hydroxide and the lithium sulfate is 2:1. Means that the moles of lithium sulfate should be half the number of moles of lithium hydroxide. So by dividing this value over 2, 0.062 over 2 equals 0.031 moles. And then he gave you the molar mass of the hydrated salt. The molar mass of the hydrated salt, and he is asking about the mass. You know also from the triangle, mass equal number of moles into molar mass. So by multiplying number of moles that you got from the previous calculation, 0.031 into the molar mass, you will get the mass. So by multiplying the number of moles into molar mass, you will get the total mass. This mass is the one you calculate. We got it from the calculation. So this is the calculated yield. The actual yield, you got it in the problem, which is 2.20. So 2.20 over 3.97 into 100, you will get the percent yield.